Namaskaram. On behalf of the PMIPCC Hyderabad chapter, a very warm welcome to all of you. I am Kritika Meher, a volunteer with PMIPCC, CAPM certified, and an immediate alumnus of NICMAR Pune. I will be a moderator for the evening. Last month, PMIPCC celebrated its 20th Foundation Day. It has a rich history of many impacting contributions to the PM community. Masterclass is one of the many pioneering initiatives of PMIPCC. Through this initiative, we aim to create awareness on emerging trends in our project management community. Today's virtual event is supported by all the 11 chapters of PMI Region 11. I take this opportunity to welcome the Gujarat chapter, our newest chapter in the region. As we begin, let me shout out a few ground rules for the evening. May I request all the attendees to take advantage of the chat window for networking. Please post all your questions using the Q&A button. These will be answered during the Q&A session by the presenter. There is an exciting quiz at the end with goodies to be won. So please go ahead and download the Kahoot app on your mobile phones and be ready. Instructions for the Kahoot quiz are being shared in the chat window. May I now request Mr. Venkat Reddy Chirla, the Vice President of PMIPCC, to speak a few words and welcome the gathering. Apart from being a seasoned practitioner in both predictive and adaptive life cycles, Venkat is a committed volunteer of PMIPCC for more than a decade. Over to you, sir.
Thank you, Kritika. Very good evening, all of you. On behalf of the PMIPCC chapter and the supporting R11 chapters, so I welcome all of you to this unique masterclass session. When I say this is the unique session, so the Artificial Intelligence Masterclass, we're doing it for the first time. In the AI, Artificial Intelligence, as all of you know, in many forms is taking over the world, whether it is machine learning, whether it is NLP, whether it is computer vision. So project management is no exception to that. So we should learn to live along with AI and also understand what impact it is going to have in our community. So I'll leave it to the experts. So we'll listen from the experts in today's session, so how it's going to impact our profession primarily. So before diving deep into the session, so for those of you who are first time hearing about the PMIPCC chapter and who are aware of the programs that we're doing, here is a quick snapshot of what programs we are doing, what services we are providing as a chapter. So as you might see the video already, so it is we are not a new chapter. We started in 2001, so we are close to 1,200 members already. So we provide a significant. We do this Jan Lahiri conference, our flagship conference every year. We have a unique program called Student Leadership Competency Building. So we work with various organizations and students, to mainly focusing on the students, to converting them as industry-ready and national-ready leaders. So that is one of our flagship products. So we have partnerships with various firms, so in national building and especially community services. We have partnerships with NIRD, TWAD, so that good amount of volunteer opportunities within the chapter, so that you can definitely pursue being part of the chapter. So it's all possible because of the volunteers we have in the chapter. So thanks to all the volunteers who are able to join today. I think the chapter is driven by the volunteers, and we have 10 volunteer leaders as part of the board. So who are engaged in driving the chapter initiatives forward. Yeah, next slide. It's just a snapshot of what programs we are doing, despite of the challenges we are facing from last several months, more than 6 months now. We are able to continue our programs virtually. So we started a career enabler session to provide support to the professionals and especially the job seeker community. There is a series of programs that was received very well by the members and also all the participants of these sessions. We did 4 sessions. We are planning to continue on these sessions. Next slide. And as part of Masterclass series, before this session, there are many other sessions we so far. So it is about Spencer's productive session or Lee's Masterclass session on leadership. There are many sessions we did as part of that under the Masterclass umbrella. And also, in addition to Masterclass sessions, there are the continuous webinars we are doing. As you can see, yeah, please next slide, please. So as you see, the plethora of webinar sessions that we have did so far, covering health and wealth, and also physical and mental well-being, law of attraction, and also very recently we did session on gig economy, which is again very well. So we're continuing our focus, and we are trying to engage in various forms. So a lot of virtual sessions in terms of webinars, master classes, and also the career enabler series we are focusing on. Next slide. So as I mentioned, the board members, the 10 dynamic leaders we have as part of the board, all of them are part of the audience today. So you can reach out to them. Any specific questions you have about the chapter or any specific events you want to know about membership or any specific details you want to know, you can directly reach out to them. Thank you. Thank you for being here. All of your presence today. Back to you.
Thank you, sir, for your warm and welcoming words. Now I would like to invite Mr. Girish Kadam, PMI Region 11 mentor, to deliver the opening remarks. Over the past 18 years, Girish has volunteered for chapters in US and India. For the last 3 years, as the leader of Region 11, he has played a vital role in enabling collaboration between the chapters and PMI. His guidance and support has led to chartering of the Gujarat chapter in record time. Over to you, sir.
Thank you so much. And on behalf of Region 11, which consists of PMI chapter across India, Bangladesh, and Sri Lanka, I welcome all the participants to this masterclass session. This is going to be something which we have been hearing all the time as an AI, which is something new buzzword came about a couple of years back. And from the technology or product perspective professionals, what we have seen actually last 2 years, there were kind of a small size projects coming into India. We also had an opportunity, I think about 2 years before on one of our national conference, we heard about how AI can be effectively used, and US Railway example or project was a great presentation, and there was a lot of learning how it can be used both for the energy saving and at the same time resulting cost saving or increased profit for the organization like railway as well. So we will listen to the multiple experts, their point of view. While we do that, I would just like to highlight a new project which has come up, and I'm sure most of you are aware of that. If you are not aware of that, I would really encourage you to look at that site, and that is called Dubai Expo 2020. It's a World Expo which happens every 5 years, and this is happening in Dubai first time. It was scheduled to start next month. That's the reason it was called Dubai Expo 2020. Considering current situation, it is now already moved by a year, so it will be starting in October 2021. This World Expo or Dubai Expo is something which will be starting October, will be open for 6 months. Every day, that is 7 days a week, it will be open for the visitors. Dubai has done a great job for that, and I just saw somewhere in the participants somebody joining from Dubai as well. So I'm sure he must be aware of this. So Dubai has done a great job. They have literally created a new oasis in the desert for this. It's a size of something like a 600 football fields. So it consists of not only expo, but number of new hotels, number of new pavilions, etc., etc. And there are 160 countries participating into that. Why I'm suggesting to look at that? This is going to be a great example from all perspectives. It is an example of how digital can be used to the great extent. At the same time, making sure that digital is working with the business objective to deliver value to customer, that is the countries or the organization participating into that, and at the same time the end user who are going to be visiting that. They are expecting something like 1 million+ visitor in that 6 months. As I said, 160 countries are participating. There are going to be 3 pavilions: opportunity, mobility, and sustainability. And everywhere we will see the latest into the technology, latest into the digital world across all these 3 pavilions, where 160 countries will showcase their products and services. I would just briefly talk about, for example, mobility pavilion. Mobility pavilion will feature the newest or latest vehicle, where it is a driverless car, etc., etc. It will also feature or explore the space, where they are going to talk about their newest Mars mission. And it will also have a 340-meter track that will be showcasing actual innovative mobility devices working on that 340-meter track. So it's going to be just amazing. And I would definitely suggest you to look at that, as it's a combination of AI, big data, digital world, and the latest into the technology. The people from the Dubai, you also have an opportunity to volunteer your services for Dubai Expo as well. And I'm proud to say Accenture is a SI partner for that, and I had an opportunity to participate into the sales of this particular deal. So let's looking forward to hear all the experts on this call and learning from them about the AI as well. Thank you.
Yeah, thank you for the insight, sir. It has set a tone for the rest of the evening. Now I would like to invite our very own dynamic host of the evening, Ms. Komal Mathur, General Secretary, PMIPCC, to introduce the topic of the evening. Komal is an experienced healthcare professional with over a decade of volunteering for PMI in various positions. She is also the chair of the Women Engagement Committee for Region 11. Over to you, madam.
Good morning, good afternoon, and good evening. A very warm welcome to all the AI enthusiasts in our PM community, volunteers and leaders. Artificial intelligence, or as we know, AI, is starting to empower everyone from 5 to 85 and enhancing almost every life experience. From Siri to self-driving cars, AI is progressing rapidly. As quoted by Maurice Conti in his recent TED Talk in 2016, in the next 20 years, more will change in the way we do our work than it has happened in the last 2000. Data is the new oil, a popular adage coined earlier, indicates unlocking the true potential of data is what it makes it so rich. The boom in artificial intelligence and its related areas is a revelation of how reams of data can help us accelerate business transformation. AI can encompass anything from Google search algorithms to IBM Watson to autonomous weapons. In the project economy, AI has emerged as the biggest disruptor. Innovation will have to leverage AI algorithms to transform an initiative from a mere idea to a realizable value. In today's presentation, we will declutter some of these terms that are used in the AI world and clarify what each one of them means. We will go one level deeper and also examine the taxonomy of AI algorithms and the different learning techniques of AI. we will look at the AI development lifecycle and how AI applications are different from IT applications, and also delve into monitoring and sustainability of AI applications. Masterclass will pivot around various use cases that can be solved by the algorithm and make you aware of the challenges and opportunities in front of you. Without delaying further, let us wear the lens of curiosity and enjoy this learning experience.
Thank you so much, ma'am, for setting the context. A small reminder to all the attendees, there will be a quiz with prizes at the end of the session, so please download the Kahoot app. It's time now to dive into the world of AI with Mr. Gopalan Opiliyappan, the presenter of the evening. He is the leader at Artificial Intelligence, Center of Excellence, Intel India. As the leader of Intel COE, he leads teams with expertise in classical machine learning algorithms, deep learning, and natural language processing. He is responsible for developing AI algorithms to improve Intel's supply chain operations, accelerate Intel's product development and validation cycles. As a leader in AI, Gopalan actively partners with PMI India, NASSCOM, and CII. To drive various AI initiatives in the industry, he is on a mission to demystify AI. As a speaker, his presentations are highly inspirational and insightful. Over to you, sir.
Thank you very much, Kritika, and wonderful to be with all of you. And thank you once again to the PMI organizing committee and to all the participants. Very happy to be with all of you. So let me go ahead and share the files. Kritika, can you see the files?
Yes, sir. Yes, I can.
Okay, great. Hope I put it in full screen, so hope everybody can see it clearly. All right. So, good day, everyone. What we are going to do today as part of the AI Masterclass is we will look at some of the aspects that Komal mentioned. And what I'm also going to do, unlike any other, something unique in this Masterclass you will see is I will also do a live demo using a platform called Azure ML to kind of demonstrate how simple it is for even, PM community like us to develop and experiment some of these algorithms with the zero line of coding. That is my key emphasis, because a lot of us think that, it is the job of data scientists, let them do their job, I'll do my job of program and project management. I want to kind of demystify that by showing to you how quickly somebody can develop an AI application using Azure ML. Okay, without much ado, I'll get into the details. Before I dive into the agenda, as part of my Guru Vandana, I want to offer my gratitude to my mentor, coach, and amazing help I'm getting from Dr. Shailesh, who is the Chief Data Scientist of Reliance Jio. So, as part of, he has been the main instrument in charting my journey in AI. So, wanted to offer my gratitude, heartfelt gratitude to him before I start the session. The agenda is we are going to, kind of walk through the alphabet soup of AI, whether you come across various terms like artificial intelligence, machine learning, deep learning, and then people also throw this term data science on top of it. We'll try to understand what they mean. And as pointed out by Komal, what we will do is we'll slightly shift gears and then look at the opportunity and the challenges that AI projects and programs are having today. Because this is the area where program managers and project managers, in my view, have got a significant role to play. We will cover that, what the opportunity is and what the challenges are. How can you play a significant role in evolving this, this discipline of AI? And then we will come back and then talk about the various machine learning algorithms that are out there. I will give a quick overview because, given the time, I'm not going to go deep into it. But what I'm going to do is to give you a taste of machine learning algorithm. What I'm going to do is take one specific algorithm and demonstrate that using a case study. And finally, we will also implement that specific case study or solving that case study using Azure ML. In the spirit of data science, we will do a couple of experiments in Azure ML and then draw some inferences. The most important part as program and project managers is I will talk about the trade-offs that a PM needs to look at or need to watch out for in a AI project. What are the trade-offs that they need to look at and drive the project so that it is deployed and delivers value. Very, very important. So I will cover that as we do the as I walk you through the experiments in SRM, and then we will recap on what we learned in the masterclass. With that, I will dive into the session. So this is the alphabet soup of AI, right? I'm sure you have all come across these various terms, but this file will give you an idea of how to place each of these terms in a systematic way, right? Let's start with artificial intelligence. Creating machines that can think like human beings has always been a dream of thinkers, innovators, and inventors amongst us. Computers were invented, 6-7 decades ago. We wondered whether such machines will become intelligent. So if you look at this term artificial intelligence, right? We all understand the term artificial. Anything that is not natural is artificial. But what is intelligence? It's a very profound term, actually. There are various connotations to intelligence. In my view, I think we still haven't understood the word intelligence. What is artificial intelligence? Artificial intelligence is all about mimicking the intelligence of a human being in a machine. The machine here refers to a computer. So then you may ask, then what is that we want to create in a machine or a computer? If you look at us, we are intelligent human beings, right? We are endowed with this in 3 the ability to see, ability to hear, ability to taste, ability to speak, ability to touch. These are the 5 senses we are endowed with. Intelligent systems are also, have the ability to sense what is happening in the environment and take actions based on prior knowledge and the stimulus data that comes through the senses. For us, the 5 senses are also, can also be called as the sensors through which we receive data, and then we process that data, and we have prior knowledge that is embedded in us in terms of memory. We synthesize data, we reason based on the stimulus that we get from the environment, and then we take an action. This is what exactly we want the machines also to do. But we don't want machines to, do every action on its own, right? There is gradation. Typically AI applications will fit into one of these 3 gradations. What are they? That is, the first one is we want the machines to either assist us in decision making or augment our decision making or to even automate the decision making. So, one of our earlier speakers spoke about autonomous driving, right? That is the highest form of AI where the vehicle itself starts taking decisions instead of a human being. That is the highest form of AI. Whereas, when you look at the earlier initial levels of AI, it will be assisting a human being in decision making or in augmenting the decision making by providing additional insights so that you can take a very informed decision by considering those insights into your decision making process. That is artificial intelligence. Now you may ask, what is this excitement? Mr. Girish was speaking about the huge uptick that we are seeing in the past 3-4 years in AI, right? Why is it happening? It's due to 3 important factors. First and foremost is the enormous proliferation of sensors all around the planet, right? What is that sensor? You all have it in your hand. This is the 109th part of our body, right? Nothing but the mobile phone. I am referring to the mobile phone. I always call it the 109th part of our body because, it has now become an integral part of the body. We sleep with the mobile phone next to us and we wake up and see the mobile phone the first thing in the morning. This is the sensor. This is feeding tons and tons of information into the data centers across the world, to the companies that are busy collecting this data and then processing them so that they can come up with powerful insights. This is the first factor, the massive generation of data. The second is, thanks to Intel and Moore's law, the hardware and the storage costs have come down exponentially. Computing and storage has become enormously cheap, So it is very easy to process huge volume of data and still generate very powerful insights at a very, very affordable cost. The third factor is the evolution of frameworks like, TensorFlow, Python-based algorithms. These are, making it very easy for anybody to enter into the AI space, either as a consumer or creator of AI algorithms and applications. That is about artificial intelligence. Let's dive into the next one, right? Machine learning is a subset of artificial intelligence. What is machine learning? Machine learning is ensuring that you teach an algorithm or a computer program to learn from the patterns that are inherently present in the data. You don't explicitly code, unlike in an IT application, you will be coding a program with set of rules. We will be very explicit about the rules. Whereas in machine learning, we expect the algorithm to infer patterns from the data without being explicitly programmed. That is machine learning. We will dive a little deeper into this in the subsequent points. What is deep learning? Deep learning extends this concept further and then says, can we automatically extract even the useful pieces of information that is needed so that predictions in terms of assisting or augmenting or automating the decision making can be done? Deep learning, to give you a couple of examples, is widely applied in complex image processing tasks like image recognition, object detection, which is very powerful technique in autonomous driving. Is it a passenger, is it a pedestrian who is crossing or is it a pet who is crossing, right? So we need to detect the objects, and speech to text, text to speech kind of, specialized tasks are done using deep learning algorithms. That is the overall taxonomy of AI, right? So AI, machine learning, and deep learning. And on top of it, you will also come out of this term called data science, which is liberally used. Don't worry too much about it. It is loosely used to either call something, something which is very specific to AI, or machine learning or deep learning is generally called the data science. So it is a very common term or a generic term that is used because you are fundamentally, deriving patterns and deriving decisions from data. That's why, data science is usually applied on all three. There is one more adjacent field called as reinforcement learning, which is also part of artificial intelligence, but it doesn't fall under the classical paradigm of learning from the data. Here, an agent, learns from the environment. There is no data here. It keeps performing experiments on the environment, and then it, derives patterns about the environment and it derives the behavior of the environment and comes up with its own model to figure out what actions if I take on the environment, it will give me a reward. And what actions if I take on environment, I will get a negative reward. That's what, the concept of reinforcement learning is all about. It is as simple as the series of steps that we take to cross the road, right? You know when to adjust, how to adjust, because the road is your environment. You are the agent. What are the steps you will take to ensure that you safely cross the road and reach the other side? That, in my view, is reinforcement learning. Because in every situation, the crossing of the road is different. And, in India, it is going to be it is a unique experience, right? Every city and every road in a city offers its own unique challenges in how to cross the road. That concept is called reinforcement learning. So, to summarize, the broad fields within AI are machine learning, deep learning, and reinforcement learning. Now, switching gears, as I mentioned earlier, what is the opportunity for program and project management practitioners? The diagram that you see to your right is called the cross-industry standard process for data mining. Dear friends, today, there is no clear development process available to develop AI applications and AI projects. The closest that we can get to is the data mining lifecycle. Here you can see, right, it is inherently an iterative process, and this is the only nearest one that we can adopt as AI practitioners. We are adopting this because of the lack of standards and processes very specific to artificial intelligence. That's why we are taking something very close to it and then tweaking it to run our AI projects. This is an opportunity for program managers and project managers to look into. This cannot happen unless you start driving AI projects and programs. Otherwise, you will not be able to fully internalize and understand the challenges that are unique to AI lifecycle and come up with standards and processes. I'll give you some important data point here, right? Having been an AI practitioner for about 5 years, the one important, one very interesting fact that I want all of you to notice is, today if I pursue 10 AI ideas, only 2 of them will go to production. So the mortality rate of an AI project is 80%. I'm very sorry to say that this term called mortality rate is COVID times, right? But that is the reality. In AI projects, 8 out of 10 projects, 8 out of 10 ideas, they don't even go to production. Only 2 of them get, eventually land in production. I want you to keep that in your, in your, as part of your learning, because this is something as a community, as a program and project management community, we need to seriously think about how can we improve the success rate of AI projects? How can we move the needle from 20% to say 40% and 60%? Because AI is a toddler, it is just 4 years, 5 years, we have started playing with AI and deploying applications at scale in production, right? Unlike software engineering, which is a granddaddy of AI, it's a very mature discipline. AI is an evolving discipline. It is a toddler. It needs nourishment in terms of program management standards and processes. This is something I want to leave you with so that you can think about it and see how you can invest yourself further and further in this area so that you can contribute to this discipline of developing standards and processes for AI projects and AI project lifecycles. As you can see, it is a very iterative process, and AI applications are very, very different from IT applications. IT applications do deploy IT applications, and you expect IT applications to start delivering value from day one. Whereas AI applications are like children. You put, they learn continuously. You put them in production, still they are going to learn in production, and they mature by learning from data. This is an expectation that you need to set with yourself and with your stakeholders. Very, very important difference between IT applications and AI applications. It is an iterative process, extraordinarily iterative, to the extent that you may even go back and then revisit your business understanding itself. To that extent, it is very volatile and dynamic. And they mature in production. It doesn't mean you turn on an AI application, it will start yielding value from day one. You have to allow the application to still mature in production. You have to allow for the learning phase in production when you land the AI application. These are a few pointers I want you to carry with you. And the other thing is, AI applications have to be monitored continuously for accuracy because they are very, very dependent on the data. If there is a business process change, if there is a data quality issue, your algorithmic accuracy, the accuracy of the algorithm will change. So you have to think about end-to-end deployment of machine learning models and artificial intelligence models. You need to very clearly think about how will you sustain these models in production, because they are very, very vulnerable to business process changes and data quality and data changes itself. So, there is a discipline called MLOps, which is emerging very fast now. And platforms like Azure ML are maturing this capability very, very quickly because you need to continuously monitor the models in production and provide the feedback back into the right level, right stakeholders and the data science team so that they can either do automated training or take the necessary action so that the accuracy levels are restored, or there's a concept called retraining the algorithm so that for the new set of data, for example, there is a business process change. So the data is going to be, very different. Then you have to retrain the algorithm and put it back into action. So these are some of the subtle differences that you need to be super clear about how to lead and how to run AI projects. And as I told you, this field is crying for standards and processes. We as a program and project management community have a very, very important role to play in evolving the standards and processes for this specific discipline. Now, coming back to the topic of AI and machine learning. Machine learning, if you look at it, there are two broad categories, right? The first is the supervised learning, and the second is unsupervised learning. What is supervised learning? Supervised learning is very, very simple. You teach an algorithm. It is very much like how do you teach a child. I'm sure as parents, many of us would have taken our child for a walk. And in the evening, when you go for a walk, when the child sees a pet or a puppy, you educate the child, you train the child by telling that, hey, this is a dog. If it happens to see a cat, you then again train the child, this is a cat. So you keep training the child, this is a dog, this is a cat. You keep training. And one fine day, assume that you forgot to teach the child that whatever it is seeing, whether it is a cat or a dog, and one fine day, it tugs your hand and then tells Papa, that is a dog. That is the day when the child has started, now the child has started interpreting the reality and inferring the real world. So far, you have been training the child as a supervisor, and finally, it has started interpreting the world on its own, even though you didn't even train the child explicitly that this is a dog, but it still went ahead and then predicted on its own. This is the way supervised learning functions. You first train the algorithm with a bunch of inputs and outputs. You provide a set of data points and also teach the algorithm, like how you teach a child, that this is the output I expect if this is the internal data pattern. Like that, you keep training, and then once you train, then you ask the algorithm to predict with the data that it has not seen. Like, for example, you have trained the child with, various breeds of a dog. You have not trained the child with a husky breed. But one fine day, the child, even though it has not seen the husky breed of the dog, will be, if it interprets and then tugs your hand and says, Papa, that's a dog. That is the day the algorithm and the child have learned how to classify a dog, even though it has not seen that specific breed of dog, the husky breed here, right? Even though it has not seen, it has created a pattern in its mind. It has created a generalized pattern, which is very unique to that child. And using that generalized pattern, it is now able to predict and interpret the reality, even though it has not seen. So that process of an algorithm where it learns from the data and generalization is an important case, where it learns from the data and figures out what are the common attributes of a dog. This is for generalization. And the way you train the child is the way you train an algorithm also. This kind of paradigm is called supervised learning. Again, there are slew of algorithms in this. One of the paradigm is called regression paradigm. Regression paradigm is all about how do you predict continuous variables. Continuous variables here could be, when will my project land in production? Will it be work week 11 or work week 12 or work week 13 of next year? That is continuous, right? The days are continuously changing. So when you are predicting a continuous variable, you use what is called as a regression paradigm. The second class of, the second type of algorithms or paradigm is called the classification paradigm. Here, what we do is, for example, if you have to predict categorical variables here are, for example, I want to predict the weather for next week in Hyderabad. Is it going to be rainy, sunny, or cloudy? I'm now looking at three classes of variables. Such type of algorithms, such type of prediction paradigms are called classification algorithms. And decision trees and support vector machines also broadly can be considered under both paradigms. There are decision trees that can be used to predict continuous variables, and decision trees can also be used to predict categorical variables. Similarly, support vector machines also can be used to predict continuous and categorical variables. I have again called out very few popular algorithms. Again, there are hundreds of algorithms, but these are very famous and commonly used paradigms in supervised learning under the broad category of machine learning. Now, switching gears, when we get into unsupervised learning, what happens? Here, you don't train the child. For example, if I have to pick another example from the real world, if you look at it, we have all learned how to balance a bicycle, right? How to ride a bicycle and eventually balance a bicycle. What happens how do we start? Typically, either our parents or friends or our siblings will be running along with us and then helping us to balance the bicycle. One fine day, you are, just imagine you are pedaling and, your friend or your somebody is helping you to balance the bicycle. You have started pedaling and you are experiencing the joy of the cool wind that is flowing past your face, right? And you gently turn back and look around. There is nobody to support you. You are magically balancing your bicycle on your own. That is unsupervised learning. That phase where you develop the muscle memory to balance the bicycle is unsupervised learning. It is very difficult to explain to somebody how you balance the bicycle. All you can do is you can show how to balance a bicycle, but it is very, very difficult to explain. It is like explaining it is as difficult as explaining the taste of jalebi to somebody, right? It is very, very difficult. You may be able to explain with the various attributes. Unless they eat the jalebi, they will not be able to understand the taste of jalebi. That the stage of balancing the bicycle on your own, right, is unsupervised learning. So there are again famous, very big paradigms, 3 big paradigms I've called out. This clustering is a technique where you present the algorithm with a bunch of data and the algorithm discovers the patterns that are present in the data. You don't teach the algorithm that, hey, this is a cluster. This is, these set of data points are cluster A. These set of data points are cluster B. No, you don't teach the algorithm. You expect the algorithm to discover the patterns that are present in the data. That is clustering technique. And, I'm not going to touch on the other two. PCA stands for Principal Component Analysis. This is another unsupervised learning technique. Recommender systems, I'm sure all of you would have heard about it. What are the homepage that you see in Amazon, in YouTube? This is all product output of recommender systems, right? They understand your patterns, your browsing patterns. They understand your shopping patterns and then recommend. From the millions of items they have, then they recommend the few selected items, which you wouldn't have searched earlier, but they predict that they anticipate that you may be interested in it. That is recommender systems. So this is a broad taxonomy or the various popular algorithms that, we typically use in machine learning paradigm. Now, I'm going to take you through a way, as I mentioned earlier, I'm going to do a deeper dive into one specific paradigm, which is known as the regression paradigm, right? Which is used to predict continuous variables. As I told you, I want to demystify this whole concept of algorithms and machine learning, right? I'm sure all of you have seen this equation in your 10th standard. At least I saw when I was in 10th standard. I'm sure, whoever, the next generation or whoever has, come out of college now, they would have probably seen it in their 7th standard or 6th standard. I don't know. This is a very famous equation, right? Y equals mx plus c. I talk about each of the terms here. Y, we also call it as the dependent variable in machine learning parlance. And then M is nothing but the slope of the straight line. X is the independent variable and C is the y-intercept. When a dependent variable is dependent on a single independent variable, it is called univariate linear regression. That means there is only one variable it is dependent on. That is why univariate. Variate means varying. Here, X is the variable which is varying, and using the variability of X, I'm trying to predict what the value of Y would be. This model or this paradigm or this form of regression is called univariate linear regression. Let me take an example and show you what is univariate linear regression. Let's assume that, for a moment, assume that you are the VP of marketing and you have been getting this, advertising budget, advertising dollars for the past 9 years, and the numbers are here. And the corresponding sales figures for each of those 9 years is given here. Now, you have to make a pitch. Assume that you have to make a pitch to your CFO and asking for, say, additional budget, right? Your proposal is to ask for additional budget, and you want to be prepared for the various questions that your CFO may ask, which could be, most of the time it will be, hey, what if I reduce my budget? Or what if I completely eliminate your budget? How will you respond? What will be your educated response to such questions? If you anticipate that these are the questions that will come from your CFO, how will you respond to those questions? Let's do that with a simple linear regression model. I'm going to take you to Excel here. So I have taken the data, whatever you saw in the file, I have taken it into Excel so that we can do a simple linear regression using Excel. Okay, so if you look at it, this is the data, and sorry, not able to. I need to. Okay, so I'm going to use a simple trend line here. Let me put my Excel back in full screen. Okay, I have got my simple trend line, which here the x-axis is my advertising dollars in millions, and the y-axis is my sales revenue. We have just plotted it, and let us do something more interesting here, right? I'm going to fit a trend line, and then also I'm going to also find out what is the y is equal to mx plus c for this 9 data points. Okay, Excel has given me this value. It says, hey Gopalan, for the 9 data points, what I have done is created what is called as a caricature of your reality, right? I have fitted a linear line, but it will not exactly go through all your 9 data points, but it is an approximate model of your sales over the past 9 years, given the advertising budget over 9 years. So, friends, we have done what is a very important thing here. That is, we have modeled the reality. Models are, one of my profs used to say, models are caricatures of reality. They don't exactly reveal the reality, but they can come very close to reality. Why am I saying that? As you can see here, the trend line is not exactly matching with the data points. Right? While in few data points it is matching, there are few data points it is not matching. That's why it is a caricature of reality. It is not exactly the reality. Now, let's get into the business. Now, assume that you are going to ask for a budget of 60 million from your CFO. Now, I'm plugging my y equals to mx plus c here. So if, so you're asking, let's assume that you're asking your CFO, hey, Mr. CFO, I need $60 million for 2021 to run my marketing programs. So what is the logical question that you can expect from your CFO? The next question he'll be asking is, hey, if I'm putting extra 2 million, what is the additional revenue you can bring to the company? You will be able to give a confident assessment based on your 9 years of past data to say that you will hit somewhere between 1570 to whatever ballpark, right? You've got now a reasonable assessment of what will be your revenue if your budget is $60 million. You can confidently say, I'll be hitting somewhere in the zone of 1570 or 1550 based on the level of confidence you can derive, right? So that is the more, very educated response or a very analytical response we can provide. Now assume that your CFO is saying, hey, I cannot give you $60 million. How about if I give you $55 million? What will be, and if he asks you, tell me what will be the revenue you can generate? Now, you can immediately give a response saying that, Mr. CFO, if you are dialing down the budget from 58 million to 55 million, I can generate a revenue of only 1455 or 1450, to approximate it. Because, certainly models are not going to be the reality. With certain level of tolerance, you can give a very, very educated response. Look at the beauty here, right? With 9 data points, we are able to predict the future and interpolate also for any scenario. let me, for academic purpose, I'll give you one more worst case scenario, right? If the CFO says, no, Mr. Marketing VP, I cannot give you any of this. We are going through very different times. What is going to be your revenue if I completely eliminate your advertising budget? This is your answer. You're going to say it's going to be catastrophic. You're going to generate only 160 million in terms of revenue. That's nothing but the y-intercept, right? Because excess becomes 0. Mathematically speaking, excess becomes 0. So your value is 167. This is the beauty of linear regression, where with very simple set of data points, with one single variable, we were able to predict sales. Again, this is just to motivate you the power of linear regression algorithm, right? We will elevate the conversation. Now, let me go back to the foil. We are not going to, reality is not going to be based on one variable. It is going to be a factor of multiple variables, right? Whether it is delivering projects on time or managing the budget of a project, like how the marketing VP is doing the model here. Similarly, as a program manager also, you can adapt this regression paradigm to even predict the cost you will incur for your budget, for the cost you will incur for your program, and the value you will generate, for example. Or when will you land your project, given certain factors that are driving your project. I have such very powerful analytics you can do with this paradigm called linear regression and the regression paradigm. Multiplying by 23.42 is nothing but the m component of y equals mx plus c. Now, being a Saturday, let us elevate our spirits and elevate the conversation of our linear regression to multivariate linear regression. So what I'm going to do is I'm going to take a case study which is taught in MIT as part of their course called Analytics Edge. And this is about analyzing the wine industry. If you look at it, Bordeaux is a province, and we all know Bordeaux wine is a very world-famous wine known for its quality. And French wine itself, we are all great connoisseurs of French wine. Bordeaux is a province in southwest of France, and like the California's Napa Valley, there is a huge wine industry here. The vineyards, there is a huge wine growing industry here. There are plenty of vineyards, and let me give you the industry structure of this wine industry in France. There are wine growers here, and there are wine testers or tasters, as you may call. They are fundamentally, their job is to taste the wine and assess the quality of the wine, right? This is one of the best jobs in the planet. You drink wine and you get paid for it. Where will you get such a job? So that is the job of a wine taster. And when they predict the quality of the wine, there is also a wine auction that happens. So when they attach a specific quality tag to a particular grower's wine, it kind of indirectly decides the price of the wine in the wine auctions. So the wine tasters, the wine growers, and the wine auction. This is how the industry structure is. Now, the question that is here is, which, when I spoke about the Panchayendriyas or the five senses, right? The sense of taste is being applied in this industry. The wine taster's taste is what drives the industry here, right? If they say a particular wine from a particular vineyard is great, it is going to fetch a higher price. If they say the quality is medium or moderate or poor, it is going to correspondingly get a lesser price. So that is the sense involved in this industry, right? That sense buds of the wine tasters plays a vital role in deciding the quality and the price of the wine. Now, the question here is, can analytics, can machine learning be used to come up with a system of assessing the quality or predicting the price of wine, right? Because quality is a proxy for price. So the question here is, without even tasting the wine, can we predict the price of the wine? So that is the way, I want to set the context for the case. Now, Professor Arlie Ashenfelter, who teaches economics, who, in Princeton, used to fundamentally challenge this industry, saying that we can predict the taste and the quality, the price and the quality of the wine without even tasting the wine. So what is he disrupting? As a program manager, you need to make stakeholder assessment, right? Whom are we disrupting as a as a project or as an advanced analytic program here? We are disrupting the wine taster's job here. So this is what in reality also you will encounter, right? AI is a massive transformation. You need to know who are going to be impacted, who are going to be benefited, who are my nemesis, who are my adversaries, who are my champions. You need to do this classical stakeholder management model to really tackle the change management of your project. Now, Professor Ali Ashenfilter said, I can use a bunch of dependent variables, and price is the dependent variable because we are predicting the price, like how in the earlier simple univariate regression model, we tried predicting the sales revenue using the advertising budget, right? Same way, we are going to predict price using a bunch of independent variables. We will see what those variables are. This is the hypothesis from Professor Ali Ashenfilter, who said we can model the relation between the set of independent variables and dependent variables as a linear regression model, which means the independent and dependent variables are linearly correlated. That is the hypothesis with which he starts. He went ahead with this proposal. Let's go a little deeper into the case. This is what we call it as dating the data, right? These are the various independent variables. Age of wine is one of the independent variables. Average growing season temperature is one more independent variable. And then you have harvest rain and winter rain. Again, I will show you when I show the data set to you. We are going to look at about 6 independent variables. Here, as part of this is a case in data science called exploratory data analysis. So, as a data scientist, Professor Ali Ashenfilter took 25 years of data from 1952 to 1978, and then, plotted these various plots where age of wine is in the x-axis, because you typically plot the independent variables in the x-axis, and then the dependent variable, which is the price here, in the y-axis. Let us look at what the data is and what is it speaking to us. Very, very important. When we do this phase of exploratory data analysis, you need to fundamentally listen to data and do certain simulations to figure out what the data is communicating to us. What is the data speaking to us? Very, very important. Let's look at it. If I look at, let me take my pointer here, sorry. So if I look at the variable here, right? Average growing season temperature versus price. If I look at this, there seems to be a decent positive correlation. What I mean by correlation is, as average growing season temperature increases, I see a reasonable trend of price increasing. Let us look at the age of wine, right? We all know, we speak about the old wine in the old in the old bottle we say, right? Similarly, as the wine ages, typically commands a higher price in the market. Is that revealed in the data? Not really, right? If you look at it, the age of wine is going from 5 years to 30 years, but I don't see a very elegant positive correlation here. There seems to be some positive trend, but not a very explicit positive trend here. We will see that in the experiments that we will do in Azure ML very shortly. But I want you to keep these observations in mind. So typically, as somebody who is interested in learning AI needs to understand the data and figure out what the data is speaking to you. Now, if you look at harvest rain, I don't see a great either a positive trend or a negative trend, or I call it as positive or negative correlation, right? Maybe there's some negative correlation till 200 mm of harvest rain, but beyond that, after 200 mm, I see some negative trend, but not very prominent. Similarly, winter rain, if you look at it, it is very haphazard. There is some areas where there is some positive correlation, and I don't see very clear trend here. Beyond 600 mm rain, I don't see a clear trend. These are some of the initial observations or inferences that we can make by doing this simple plot of my independent variables and dependent variables. Now, I spoke about the nemesis, adversaries, and the champions that we need to be aware of in any project, right? Same thing is applicable to AI projects also. Let us take this personality called Robert Parker. He was a wine taster. He is considered as one of the world's most influential wine expert. What is his response to Ashenfelter's hypothesis? He says this is an absolute sham. It is like without even going to the movie, how can you, be a critic of a movie? That's what his statement is. You can clearly see, you don't even have to read between lines. It is very obvious he is deeply concerned with the proposal from Professor Arlie Ashenfelter, because his job is getting disrupted. Obviously, he will resist such a change. He will come up with such emotional reactions. This is what you will also see in reality when you drive AI transformations in your organizations. Moving on, a little bit of mathematics. Bear with me, it's not going to be very complex. Let me detail it for you. So the dependent variable here is the wine price, and we are going to consider various independent variables like temperature, average growing season temperature, harvest rain, winter rain, age of wine. We are going to consider a variety of factors. So X here will no more be X. It will be X1, X2, X3, X4. That's where it becomes more complicated, right? Excel cannot solve such complicated problems. That's where we depend on machine learning engines like Azure ML. Now, the Y equal to MX plus C becomes a little more complex now. Beta naught is still my the C part of my Y equals MX plus C. Typically in machine learning terms, we call it as bias. Some of the platforms like Azure ML calls it as bias. Beta naught is nothing but your C or the Y. Beta 1, X1, you can read it as beta 2, X2, beta 3, X3, beta 4, X4, and so on, right? Based on the number of independent variables that you will consider to model your problem, this equation will increase. It will be beta 1, X1 plus beta 2, X2, and so on. And then, as I told you, models are caricatures of reality. So there's going to be some errors. You're not going to exactly predict every data point in the past as well as in future. There's going to be some error. The job of a data scientist, the job of an AI practitioner is to minimize the error as much as possible. So I will talk about that in the subsequent points. So this is the model. It's a very, very simple model. But only thing is we are stepping upon a one variable or univariate regression model and moving to a multivariate regression model. In case of a multivariate regression model, it is going to be beta naught plus beta 1, X1, beta 2, X2, beta 3, X3, and so on, plus epsilon finally to capture the error. Our job, the machine learning algorithm fundamentally finds out the coefficients, the beta naughts, the beta 1s and beta 2s and beta 3s. Fundamentally, it finds out the coefficients. It comes up with an function approximation by learning from your input data and output data, and comes up with this various weights, as they call in machine learning, also known as coefficients. Nothing but your M term, right? The slope of your line that you saw in Excel, that's what we are going to do. But here it is not going to be just M. It is going to be M1, M2, M3, M4, and so on, based on the number of independent variables you will consider for modeling your problem. That's why it is called a multivariate regression model. Now, what typically, I'm going to go under the hood of a machine learning algorithm, right? What typically an Azure ML model does below the hood, under the hood, if even Excel does that, right? When we say, hey, fit the 10 lines, how did it come up with 23.423x plus 167.68? How did it come up with? It fundamentally figures out what is known as the goodness of fit. Which line, if I draw, will be able to explain as much of my reality as possible. That is what a machine learning Azure ML platform also does. Here, let us look at three possible iterations. We are going under the hood of an ML engine to figure out what is happening here. Right? How typically an ML engine comes with the best model, given 6 independent variables, how does it predict the price? What happens really? So if you look at it, there are 3 possible iterations. I am showing it for demo purpose. Let's take the red line, right? The red line is, I call it as a lazy regressor. It didn't even make an attempt to fit my line, fit my data points, right? It didn't even make an attempt. It merely predicted whatever was the past. It just said, I'm going to continue taking the average price of my wine for the past 25 years and continue to predict the average as my future price. That is called a lazy regressive. It didn't even make any attempt to fit a line for this set of data points. That's why this term is called sum of squared errors. So the error is very high here. The red line, that's why it has a high error of 10.15. Let us take the blue line. Blue line, not bad. It has made some reasonable attempt to, do a reasonable fit. But iteration 2, I would call it iteration 2. 6.0. Green line amongst all the three, if you do a relative assessment, it has done a decent job. How do I say that? Because the sum of squared errors of this particular green line is 5.73. Amongst the three, this is the minimum. So the machine learning engine tries multiple iterations to figure out, to come up with the best fit where it can get the error as low as possible. That's what it actually does under the hood. This is what we need to know. How really a machine learning engine works. As project managers and programmers, you don't need to know the mathematics behind it, but you need to know the intuition behind it. Very, very important. That's how you can lead programs and projects. Now, let's come back to this, right? What really is an error term? Because I spoke to you about a mathematical term called epsilon. What is that error term? So if I fit my line here, again, I'm taking a single univariate regression, because once you move to 2 dimensions, your model has to be viewed in 3 dimensions. Because for a univariate, we were looking in 2 dimensions, XY plot. But if you want to do a bivariate, you have to view it in a 3 dimension. And it is no more a line, it is a plane. And if you want to view it if you want to play with multiple variables, you are dealing with multiple dimensions. So it is very difficult for a human being to imagine beyond the 3 dimensions, right? We can imagine a 3-dimensional object or view an object and interpret 3D, but you cannot view beyond 3D. So I'm sticking to 2D here. So if you look at the error terms, the vertical line, the red, the perpendiculars that are being dropped onto the blue line are the error terms. Our job is to minimize the error terms as much as possible, and we will see how to do that using Azure ML very shortly. But you need to know how reality is different from the caricature. The caricature is the blue line, the reality is the black points, and the perpendiculars are indicating the error terms. The distance from black point to the blue line is the error. Okay, now something you need to keep in mind as a program and project manager is the metrics very specific to an algorithm. When you start managing a project, an AI project, first and foremost question you need to ask is, what is the data science team developing? What are the algorithms they're developing? What are the evaluation metrics that the data science team is using to assess the accuracy or quality of their algorithm, right? You need to know that. That macro picture you got to have. Otherwise, it's very, very difficult to have a intelligent conversation with the data science team. So the first sutra here, right? The first tip I will give you. In any algorithm, you need to know what is the metric that you need to minimize and what is the metric that you need to maximize. In case of a regression paradigm, the minimizing metric here is the sum of squared error, or platforms like Azure ML give out a couple of other error terms. One is the sum of squared error, the other is root mean square error, and also there is a third one called mean absolute error. Pick one metric to watch across multiple experiments. We will do that when we do the experiments in Azure ML. But the important tip for you is you need to know what is that you need to minimize. As a program, as a data science, as a program manager of a data science team, what is that your team is trying to minimize by developing this algorithm? So the minimizing metric is something you need to remember. What is the maximizing metric? In case of a regression, the maximizing metric is also known as the coefficient of determination. Also, we call it in very simple terms, it is called as R square. R square is what it fundamentally does is it explains the reality. The higher the R-square, the closer it is explaining the reality. For example, if I come up with an R-square of 0.82, because R-square typically ranges from 0 to 1, if my R-square is, say, above 0.67, generally they are considered as good fits. That means your hypothesis that your independent variables and the dependent variables are linearly related is a valid hypothesis. If your R-square starts showing up and over multiple experiments, it starts improving and comes in the zone of 0.67 to 1, you can be certain that linear regression is the right hypothesis to pursue. So, and typically, 0 is a lazy regressor, as I told you. 1 is a utopia or ideal one, right? You will never see R-square equal to 1 in reality. You will see somewhere in the zone of 0 to 1. A good regressor will have an R-square between 0.67 to 1. That means 67% of reality, if a regressor is able to explain, it's a good start. You can keep pushing further with multiple experiments and collecting more data points and training the algorithm, like how you train a child. And you can push up the accuracy, but 0.67 is a good start for a linear regressor. 0.67 R-square is a good start. Okay. Now, the independent variables for this case study we are going to consider are average growing season temperature, harvest rain, winter rain, age of wine, also population of France. Because this whole case study, the setting of the case study is France. So we are going to also look at the population of France as one of the predictors or one of the independent variables for our model. I just took a water break, so back. So let us dive into Azure ML and then develop this simple application using Azure ML. So this is my Azure ML canvas, as we call it. Studio.azureml.net is the link you can all try, and it's a free subscription. You can use it, but with very limited compute and storage. But as a beginner, you can start using this Azure ML Studio using the free subscription. If you want to do higher compute and if you need higher storage, then you have to pay. But this is the free subscription that I'm using. So I'm going to create a new experiment. Typically in data science, we call them as experiments. I'm going to create a new experiment. So we start here, and I'm back in the canvas, and I have uploaded the training data for my algorithm, which is wine.csv. I'll show you the data because we need to see whether some of the exploratory data analysis that we did in the PowerPoint, are they reality? Let us go and check. So what is the metadata of this data? It has got 25 years of data, starting from 1952 to 1978. Up to 1978, we have the data. Since we are in supervised learning paradigm, we have to train our child by providing both the set of inputs and the outputs, because we are now in the training phase. There are two distinct phases when you develop a machine learning algorithm. The first phase is called the training phase, where you teach your child, saying that, hey, if these are the various features, if this is the winter rain value, if this is the AGST value, and so on, this is the price of the wine. That is what I'm teaching my child. And I'm not doing for one data point. I'm not doing for only the year 1952. I am doing it for, I'm training the child by showing 25 data points, which are from year 1952 to 1978. Let us do this exploratory data analysis in Azure ML. I'm going to take, we saw, right, AGST had a pretty strong positive correlation with price. Let's go ahead and then do it. This is also called as a bivariate analysis. That means I am doing two variables, AGST, which is my independent variable, and price, which is my dependent variable. So whatever I saw in my PPT, the same trend I am seeing here. There is a nice positive correlation between AGST and price. Now, let's look at few more variables and then see how they are getting correlated with price. Let's look at harvest rate, right? There is some negative trend, as the harvest rate increases, the price of the wine seems to come down. Let us look at age versus price. Not a clear trend, but a very feeble signal I am seeing that as the age of the wine goes, price of the wine seems to go up. Okay, so when I draw the conclusions of the case study, I will talk about why we are seeing such a scattered pattern with regards to age of the wine and the price. We will talk about that. And a few other variables is I want to show you France population and price. Is there a relation? Not very significantly. I don't see a great correlation between these two variables. The other interesting thing I saw was age and year, right? Age of wine and year. You can see a picture perfect correlation, right? Why is this happening? Because as the years increase, the age of wine increases. So if I have manufactured my wine in 1952, in 1978, obviously it will be 26 years old. That's why there is a negative correlation, right? As the age of wine is lesser and lesser when I take the snapshot in 1978. As my years come down, my age of wine increases. So these are some of my exploratory data analysis inferences I can make. Let us now move to creating or developing the model in Azure ML, right? What I'm going to do is, we saw that there are 7 columns in the data set, right? I'm going to use for my first experiment, I'm going to use only some columns, not all of them. So I'm going to take a couple of columns. So the function I use in Azure is called select columns in a data set. This is also nothing but, how do you select a couple of columns in Excel sheet, right? Something like that. So I saw that, price had a pretty good correlation with average growing season temperature. So I'm going to do my first experiment by doing a very simple y equals to mx plus c kind of an experiment, right? So I'm subsetting only these 2 columns. Now what I'm going to do is I'm going to train my child by saying that, hey, use the hypothesis linear regression and train yourself, check whether the data points that I'm giving you are linearly correlated, and I am giving you 25 data points. That's what I'm telling you. How do I train my child? By calling the function called train model. Okay, so how am I going to train my child? I'm going to tell my child that this is the hypothesis that you need to use, and this is the data set that you need to use, and this is what you need to predict. The prediction I'm going to do is price. That's all. We will use a simple experiment. All I'm telling my child is, hey, learn from these 25 data points and learn how to predict the price. Now, I have not trained, I'm just setting up the model. And there is a very Azure ML specific terminology called scoring the model. What it means is how good my child is predicting the model, right? That is called scoring the model. And then finally, we will evaluate the model. How good is my child in what is accuracy? We spoke about the minimizing metric and the maximizing metric. We will observe those 2 metrics and see how our algorithm is functioning. So now I have done, I have done what is known as the basic plumbing for setting up my first experiment, right? Let me give a nice name here. This is a regression case study for PMIPCC chapter. So now what we need to do is run this model. I'm going to now train my child with the 25 data points, and see whether it has learned. So I'm now running my model. Okay, great. Since it is just 25 data points, it was able to do it in few seconds. Now let us go and see what my child has learned. First, I will show you, because after all, we did a y equals mx plus c. I want to show you in Azure what is the corresponding m, m and c, right? But as I told you earlier, c or the y-intercept is called as the bias. The value at this point for the model is minus 3.3. And for AGST, which is one of the columns we use for modeling, the weight, the M component, right? The model has learned from the 25 data points, and it is saying, hey, at this point, given AGST alone, 0.63 is the weight of my AGST. What it means is, if price is my Y and bias is the C term, M is 0.63 into AGST. That is the linear equation Azure ML has come up with. Now, let's look at our minimizing and maximizing metric here. If you look at it, so I am going to watch as a PM, as somebody, I am going to ask my team to look at only mean absolute error. There are plenty of error terms, but I'm going to use minimum absolute error as my watching metric. And the coefficient of determination is my predictability of my model, right? So I have developed a poor caricature at this point. It is at this point only 43% it is able to predict the reality. So I have to improve my experiments. So I'm going to do a few more trials and then see whether I'm able to improve my model accuracy. So what I'm going to do is I'm going to do one more experiment, and I'm going to add a few more independent variable. We also know, right? Who can disagree with me saying that age of wine is not important? So let us use age of wine and then see whether the model is improving your accuracy. This is our second experiment. Okay, it did really fast. Let us see how my minimizing metric and maximizing metric are performing. Not bad. I just added one more variable, which is age, and my absolute error came down from 0.39 to 0.36, and my predictability, or the ability to predict the reality, has come to 52%. Not bad. From 43%, we have got a pretty good jump. So we are going in the right direction. In the interest of time, I'm going to add two more variables in one go and then see how my results are coming up. Sorry, I clicked the wrong button. I'm going to add winter rain and harvesting. I will tell you why I am not adding few more variables. There is a very important learning there. Wait for it. So I'm going to run my third experiment. Let us see how it goes. Still processing. Let's see what the results are. We are in our experiment 3. Let's go ahead and then see what's our minimizing metric and maximizing metric. So our minimizing metric has come down drastically. It has come to 0.22. We started with 0.39 and we have come down pretty significantly. Look at the beauty here. By adding 4 variables and 25 data points, I'm able to train my child, which is now able to predict the reality with 82% explainability. That is the magic of machine learning here. 82% we have got in terms of predicting the reality. Let's go ahead and then use one more variable. I'm going to use, let me see which variables I have used. I think I have used fairly all the variables. Now I want to show you one very important aspect here, right? How typically the model learns from the data. I'll show you how does it learn from the data. So if you see here, these are the supervised learning, right? I told my child, if these are my 25 data points with the different features like winter rain and blah, 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 I told my child that price will be 7.495. And now I am, checking how good it has learned. With 82% accuracy, it is telling me if the real price is 7.495, it is predicting it as 7.712. Not bad, right? It is off by about 20 cents. It is off by about 20 cents. You can go through various data points here, right? That is why we, no wonder we got 82% accuracy. So we did 3 experiments, and then we were able to quickly march from 43% explainability to 82% explainability. What I will do is I will stop here and then show you one very important aspect of data science, which is known as multi-collinearity. What does it mean? It's not a very strong technical term. You will, when I show you the data, you will be able to appreciate. Sorry, I'm plugging it with the wrong boxes. Okay, so let me run one like this, and then that's called run selected. If you run only that specific box, what we are trying to do is how each variables are correlated. So Azure gives you a 7x7 matrix, right? It can, it has got all the 7 variables, including the dependent variable price, and it gives me a 7x7 matrix. The matrix here in Azure is little clunky and clumsy. I will take you to Excel and show you how the same data I have copied, but I have beautified it for easy interpretation, right? So what are the mega mega observations we can make? The correlation matrix is a diagonal matrix. You can see here, any cell below the yellow cell is symmetric. Whatever you see in the upper half of the matrix is replicated or mirrored in the lower half of the matrix also. So you can choose whichever half you want, right? You choose the better half. I will leave it to you. Pun intended here. So I'm going to choose, this is my better half. The yellow ones are my better half. I want to take you to some of the bolded data points. So if you look at the age and the year, there's a perfect negative correlation. And if you look at France population and the age, again, a perfect negative correlation. This is the reason I didn't include year and age, because one will pull down the other, right? Have you heard about the crab syndrome? Same way, if age and the year are negatively varying, then my overall model prediction accuracy will come down if I include both negatively correlated variables. I can keep one of them. That's why I'm keeping age and I'm dropping year. Similarly, between age and France population, I am seeing a negative correlation of 0.99. So I drop France population from my analysis. These are the major aspects I wanted to show you. Now let us do the testing phase, right? It's going to be super fast. I will not take much time here. I have got another data set called the wine test. I'm going to really put my child to test, right? I'm going to show really a couple of unknown breeds of dog that it has not seen, and I'm going to test my child whether it is able to predict well. So I'm going to quickly set up my plumbing here. And then you can see here, I'm not going to train my model because I have a trained model already. So I'm going to just score using the trained model. So how do I do that? It's again a very simple plumbing here. So I take the trained model and then I give my test data set here. And then I'm going to evaluate. Again, I will now walk you through the data and then, oops, I'm getting an error here. Okay, wrong code. Okay, there you go. All right, so let us run that. Okay, I'll show you the test data. This is something the model has not seen, and let us look at it. So this is for years 1979 and 80. We know the actual price. It is 6.95 and 6.49, but we have not trained our model with these two data points. So we are directly asking the model, hey, I have trained you with 25 data points. Tell me what is the price that you are going to predict for 1979 and 80. I have trained you from with the 1952 to 1978 data points, but tell me what is going to be the price of wine for 1979 and 80. Let us see what the model is predicting. Okay, we are done. Let's go ahead and then see what the model has predicted. Scored label is the column that you need to see. Again, Azure gives the data like this. Look at it, right? The actual price was 6.95 in 1979 wine auctions. Model predicted 6.76. It came 19 cents closer. The variation is 19 cents. Not bad at all. With just 25 data points, it did a remarkable job in predicting the price for 1979. How about 1980? 6.49 was the actual price in the wine auction. The model was off by 18 cents. It fundamentally predicted 19 cents more than what the market or auction really fetched. Okay, that is the beauty of machine learning algorithms, right? With nearly 25 data points, I was able to train an algorithm in probably about 10-15 minutes, and I was able to test it also. 2 data points which the model has not seen. So we did the 2 distinct phases, training the algorithm and testing the algorithm. These are 2 important phases in machine learning model development. As a program manager, you need to factor for these 2 phases in your project plan. And what else I wanted to show was something important here. Okay, I think I'm missing. Yes, some of the trade-offs that you need to keep in mind with regards to experiments, right? Because data science as a field is, is busy with a lot of experiments. But as a program manager, when will you draw the line saying that I am done with experiments, I am going to deploy this model, or I'm going to start having conversations with my stakeholders and talking about when can we deploy the model. Let us look at this, right? Oops. So I had done multiple experiments using this data set. I played with this data set and I did 7 experiments while I showed you 3. Let me talk about the other experiments. So when I included even the winter rain, we got the best model here, right? We stopped here. When you look at when I added France population, there was a reasonable increase in R square. The coefficient of determination in the 3rd digit, right? In the 3rd decimal, there was a 1-point improvement, and my error actually increased in the 4th digit. I'm not too alarmed by it, but as a program manager, you need to question, right? Then the maximizing metric and minimizing metric are not significantly improving. What is the point in having France population in the model? That is something you will have to ask. Why? Because collecting data is a cost to a project. Collecting more and more data points, more and more features is a cost to the company. So as a program manager, we are the custodians of the cost we are incurring in our program, right? If the data scientist team comes up with saying that, hey, I want to collect France population because in the 3rd decimal, I will get 1-point increase, you got to have a pushback. You got to do a pushback here. You got to really ask, what is the return on investment I am getting by adding this feature to the model? That is something I wanted to, emphasize. Because assume that France population, I may have to go to Census Bureau in France, collect the data, bring the data into my internal data lake or into my containers, and then do my model, right? At what cost? That is something you need to be super clear. What is the ROI I'm going to get by adding 1 additional feature? Is it the 1-point increase in my 3rd decimal? Let me not bring the feature, right? No point in doing it because there's no ROI for this. Instead, it is better to have a conversation with the stakeholder saying that, hey, my data science team has developed a model with an accuracy of 82%. How about deploying it and then, let the model learn in production with more data sets, but the baseline accuracy is 82. As the model starts learning in production, it will improve its accuracy, maybe, to 85% or 87%. But that is a trade-off that you need to be deciding at this point. What is the cost of collecting additional data points? Let me tell you another trade-off, right? Very, very important. I'm going to take my multiple experiments and do a simple plot of both minimizing metric and my maximizing metric. I'll show you the beauty here. So if you look at it, right? Here, the red line indicates the mean absolute error, how it has moved over multiple experiments. And the blue line indicates how my coefficient of determination or my ability to predict reality, how it has moved. Look at it. Beyond experiment 3, do you see any improvement? Marginally in experiment 4 and experiment 5, 6, and 7. I'm not too convinced that I need to do experiment 5, 6, and 7. This is called law of diminishing returns, right? When do you stop your program? When do you stop experiments in your AI project? And when do you start having conversations for deployment? A very, very vital clue, and a very, very vital step as a program manager you need to keep in mind. With this, I will, stop my experiments and the inferences that a program manager has to make, the trade-off decisions that they have to make, both with the data scientist team as well as with external stakeholders, by understanding the model, by interpreting the results, and figuring out the ROI impact of such results, and evaluation metrics. How will you apply as a program and project manager to run your project, to deploy your project and generate value, so that it's no more 2 projects out of 10 ideas, it's no more 2 ideas out of 10 ideas that go to production. We want to see, 4 ideas, 6 ideas, and possibly 7 ideas that go into production if we pursue 10 ideas. That is where I want to leave you with as far as the Azure ML experiments are concerned. Now, back to my files. So now we had an adversary in the name of Robert Parker, and we had an Ashen filter who was a data scientist. And if you look at the conflict here, right? 1986, Parker predicts it's going to be an exceptional year for the wine industry, whereas the data scientist is predicting it is going to be mediocre. And in 1989, you can see a clear divergence here, right? Keep this point in mind. I'm going to emphasize this point very shortly. 1989 and 1990, what are the predictions from a data scientist? 1989, he said it's going to be the wine of the stage. 1990 will be even better. What happened in wine auctions? 1989 sold for more than twice the price of 86. Exactly matching the predictions from the data scientist, right? 1990, he said even better. Exactly the same thing happened. It sold even for higher prices. Let's look at how a nemesis in the name of Parker and the data scientist in the name of Ashen filter, how are they converging? Look at the year 2000. Look at the year 2000, right? Ashen filter predicted 2000 and 2003 would be great. What is the stand-up Parker now? He has gradually started shifting from his position of being a nemesis to a tacit supporter. 2000 is the great vintage Bordeaux has ever produced. That is where you can shift with powerful analytic models a traditional industry like a wine industry and bring analytics and replace a traditional judgment-based assessment for quality or price of wine, right? With the very elegant, simple models, we can even disrupt industries like very traditional industry like wine industry. So those are the conclusions. With few variables, we were able to predict wine prices quite well, and it outperformed wine experts' opinion. It almost outperformed the wine experts' opinion. And a very quantitative approach really helped us in disrupting this traditionally qualitative industry, where we were dependent on the taste of the wine taster, right? Whereas with mathematical and machine learning models, we were able to disrupt it. I have got a time check. So where really linear regression models are applied, wherever there is continuous variable that you want to predict, linear regression is the way to go. Continuous variables you can predict using. Look at the various verticals, right? Whether it is product pricing, forecasting demand and inventory in supply chain, whether you want to predict health issues in COVID times, or, what will be the hospital load during pandemic times like this? What will be the, in agriculture sector, how can you use macroeconomic indicators? No wonder, an economic prof like Ali Ashenfelter was able to do. So regression techniques are very, very common in the field of economics. Machine learning has adopted it, actually. So macroeconomic indicators like GDP, balance of payments. Looking at our own backyard, product release timelines, prediction of when will I land my product, what will be the timelines, when will I hit my alpha, beta, what are the, when will I hit my production deployment, what is the cost I will incur if these are the resources, what is the value I can generate if this is the cost I'm investing in the project. Variety of opportunities for program managers to apply in their own backyard itself apart from managing AI projects. Again, in finance vertical, BFSI, you can apply to predict cash flow, predict working capital requirements in any organization you can use. So quick recap, we started with the taxonomy of AI ML, the specific challenges and the opportunities for a PM to develop standards and processes by jumping into the field, pick up the AI skills and jump into the field and start leading projects. Learn basic AI algorithms, how to infer, how to run AI projects. I have given you some clues. You've got a basic idea, but a long way to go. I am setting you off in this journey today, right? Many are called, but a few are chosen, as they say, right? You have all got this opportunity to get a taste of the power of AI in the various fields and the opportunity for PMs to learn this and apply and lead projects and programs. So that is the call here. And then we did a deep dive by jumping into one specific case study, demonstrating it in Azure ML, understanding the trade-offs that are needed by using the critical evaluation metric and how to manage stakeholders and the dynamics we will see as we push through AI transformation in an organization. Right? You got a simulation of it today. With that, I want to wrap it up, but I want to leave you with one last thing. What is that one last thing? If AI is the new electricity, do you know how to use it? With that, namaste and thank you very much. Back to you, Komal.
Thank you very much, sir. That was an engaging session and lots of learning. I am now all excited to enter the world of AI. To all the attendees, stay on for an exciting quiz with prizes. We have received several interesting questions. Now it's time to listen to responses from the expert.
Sure, go ahead.
Thank you, Gopalan, for that insightful session. We have quite a few questions coming up. The first one is from Naveen Arora. What are the granular steps that one needs to evaluate to decide whether AI ML is possible for a particular project or not?
It depends on the paradigm, if you are so today we briefly touched upon the prediction paradigm, right? There are again variety of paradigms. There are interpretation algorithms, there are summarization algorithms, there are recommendation algorithms. It depends on the specific paradigm. But let me assume that if you are looking at prediction problem, if you are just doing only descriptive analytics, but you want to shift into the field of predictive analytics, then AI, these prediction algorithms come very handy. These are very powerful and they come very handy.
Thank you. Next question is from Venugopal. I want to apply AI in project and portfolio management space. What would be the best areas to start with?
I actually applied in Intel. We actually used, because we are our products are very, very complex. If you take system on chip, when we design system on chips, there are about 150 subcomponents that get assembled into a system on chip. And the maturity of these 150 components go through various stages in terms of their maturity. So it's a very, very extraordinarily complex program. And, continuously bugs are filed and bugs are dispositioned, and the IPs are getting integrated and IPs are at different stages of maturity. We actually used exactly the same algorithm, the regression paradigm, to predict our SOC milestones. And finally, when will we, we have a milestone called a critical milestone called tape-in of a product. That means the design is over. Now we will turn our design into to the manufacturing team in Intel. So when will the tape-in happen? We actually used this kind of prediction algorithms to predict SOC milestones and timelines. So same way you can use in the project management space, you can use to predict your cost, predict your timelines, predict the bug trend, how the bug trend will come in the subsequent weeks, and even to predict your budget consumption versus value generation.
Thank you. The next question, curious to know what are the additional skills required in AI project management with respect to developer manager?
Sorry, can you repeat that?
Additional skills required in AI project management role.
Okay. Additional skills is you need to have some basic idea of AI. Today what you got is a taste of AI, but you need to have additional skills because I call this as a zoo of algorithms, right? You need to walk into the, not into the cage of the zoo, but into the zoo to understand the various algorithms that are there. What are the evaluation metrics? So if an AI project is embarking on specific algorithm development, you will know how to manage those projects, where to draw the trade-offs, where to push the data scientist in, where to push the stakeholders. All these are common PM skills, but when you add the AI skill to you are becoming pretty powerful in leading the AI projects.
Thank you. Next question is on what is the ratio of supervised and unsupervised learning algorithms in the real-time application in use now?
Okay, great question actually. I deliberately took regression. I didn't take recommendation or any other algorithm, right? I call regression and classification, the second algorithm which I called out in my machine learning file. I call these two as the workhorses of machine learning. These are supervised learning algorithms, and 80% of real-world problems can be solved using regression and classification problems, and both are supervised learning techniques. Yes, there is a field called deep learning, which is unsupervised learning. In my view, that is in the zone of 20 to 30%.
Thank you. Next question, what pitch to convince program project stakeholders, especially the business stakeholders for AI?
What steps?
What pitch to convince the program and project stakeholders? What should be the pitch?
For what? To create a new project?
To convince the business stakeholders.
I'm assuming that this person is talking about. Sorry.
More from project management perspective, how should a project manager pitch for AI?
Is the person trying to get an AI project from, or create an AI project, or what is the concept?
Yes, as an approval from business stakeholders.
Yeah. There are frameworks available. We are not touching it. As I told you, the first and foremost thing is the idea an AI idea? Very, very important, right? Because as a leader of AI Center of Excellence, I come across automation ideas also manifesting or being brought as AI ideas because, since it is I have learned a new hammer called AI, we don't need to go and solve every problem with AI, right? Automation problems also do manifest and come to us as AI problems. So we need to be very clear on whether we are looking at an AI problem to solve, first and foremost. Once you have established that this particular problem can be solved using AI, the next question is, what is the value you will generate? What is the ROI? This is typically applicable to any project, but it is very, very important as to when, what is the value that the business will get? And what is the timeline? When will you be able to generate this? When will you be able to convert this idea to a use case, and a use case to a proof of concept, and a proof of concept to a deployable solution? What are your approximate timelines? Very, very important thing is, AI being a new field, to sustain the enthusiasm and the commitment in the business, you need to quickly show how quickly you can get a proof of concept in the hands of the business, right? So these are the few important things that you need to keep in mind, whether the idea is an AI idea and whether whether there is an established ROI and a value for it, and how quickly you will be able to turn out the POC to demonstrate the potential that this particular opportunity has got in terms of that.
Thank you for that. Another interesting question, any good books for program managers in data science that you would recommend?
There are, books are unfortunately catered only for data scientists and developers. I haven't come across any books specifically for program and project managers.
We have a lot of questions pouring in, but in the interest of time, we will take a pause here. And for the remainder of the questions, we will definitely get back to you post the session. Thank you so much for the lovely questions and the lovely participation from the audience. Thank you, Gopalan. Kritika, over to you.
Thank you.
So all the attendees, please stay tuned for an exciting quiz with prizes. As we continue the journey, the next stop is for a quick poll. I request the attendees to answer the poll question. The poll is intended to better understand the needs of our PM community. Your responses will help us design more engaging initiatives. Thank you everyone for your responses. Today, we are very fortunate to have with us several successful practitioners, visionary leaders, passionate volunteers who are advancing project management in our region. Their words and actions have always been an inspiration and the guiding force for community service. I would now like to invite Dr. Srini Srinivasan, Regional Managing Director, PMI, to speak a few words. Over to you, sir.
Thank you, Kritika. I think, ladies and gentlemen, Gopalan has given us a great picture of the power and the possibilities of AI. And Gopalan has also challenged us to dive deep into AI and start managing projects that are AI oriented. However, for those of us that may not have that opportunity right away, for those of us that are managing projects that are more traditional in nature, I would suggest getting started in a small way by looking at AI as your friend, as opposed to worrying about whether AI is going to disrupt or whether AI is going to take away your role or mine. I would suggest looking at AI as a friend in two very key aspects of what we do in project management. One is, can AI help us increase productivity? The answer is a big yes, even in traditional projects. For example, you and I could use AI methodologies to automate repetitive tasks that you and I do. Things like scheduling, things like task creation, things like sending alerts. And if you automate some of these repetitive tasks, it opens up your time and your focus to more important things in terms of managing your project. Especially with COVID, with remote teams, with distributed teams, you need all the time that you can get to manage your team and your stakeholders. So one starting point would be how to use AI to help automate repetitive tasks. The second opportunity is, can AI be a friend to improve quality? The answer on that is a big yes as well. So you could use, for example, chatbots for speech recognition, recognize conversations, so that you could automate very specific things around tasks or assignments. So my challenge to you would be, do dive deep, as Gopalan pointed out, if you can, but if you cannot, start small by embracing AI to help you improve quality and increase productivity. And some of you asked a question, how do we get started with managing AI projects? I'm pleased to tell you that we at PMI are working with NASSCOM as we speak to develop some insights around what should be a fit-for-purpose project management framework for AI and decision science projects. As a matter of fact, Gopalan is helping us with that. So thank you again for this opportunity. Over to you, Colonel Harsha.
Thank you, sir, for those inspiring words. Now I request Lieutenant Colonel Sri Harsha, immediate past president, PMI Bangalore chapter, and the winner of the prestigious Eric Jennett Project Management Excellence Award, to speak a few words. As an officer of the Indian Army, he has many stories to share on sticky situations and challenging terrain. Over to you, sir.
Thank you very much, Kritika. At the very outset, I would like to compliment PCC and Mr. Gopalan for a very insightful journey which they have taken us through in the short course into this developing subject of artificial intelligence. And I think very aptly, the last slide which Mr. Gopalan left us with, are we prepared, is the challenge that faces all of us. One thing which I would like to highlight here is that projects is never a solo effort, it's a team effort. So the focus of all leaders who are here in this talk today should be on how do I develop the capabilities of my team in absorbing the concept of AI and applying that at the workplace. Any new idea or concept is worth its salt only when it's tested on ground. Theoretical, you can do any number of research studies and keep that results only for showcasing. But finally, what matters is how it is translated in ground. And I'm sure that is what the whole world expects from the project management community. How we are going to deliver successful projects using AI and leveraging its capabilities. And like how one of the participants asked, can AI be used everywhere? That's where the capabilities and the what we call knowledge of the project managers comes handy in deciding which tool to use. Just because you have a hammer, you can't use the hammer everywhere. So with this small insight, I would just like to share a couple of my own experiences at the Visakhapatnam Smart City. The moment people speak of smart cities, everything boils down to AI, machine learning, IoT. But then when it comes to application on ground, I think India as a market has a long way to go and we have to mature. And I'm sure this should be the foundation stone for all of us to start taking some interest and see how we can adopt this concept of artificial intelligence, machine learning into our functioning and enable successful projects and also contribute in the nation building and compete with the advanced world shoulder to shoulder. Once again, thank you very much, PMIPCC, for putting up a very good talk and for benefiting the larger community. Thank you very much. Over to you, Kritika.
Thank you, sir. Thank you for the inspiring words. Now I would like to invite Ms. Shamima Begum, the President of PMI Bangladesh chapter, to speak a few words. Shamima is an experienced practitioner with over 2 decades of experience in leading and managing operational excellence projects and PMO operations. Over to you, ma'am. Ma'am, you're on mute.
Sorry. Thank you so much, Kritika. Thank you, host chapter, for giving the opportunity. So I'll start with my experience. With that, I had an opportunity to go to Japan last year. There, my topic was training topic was innovative production management through IT and IoT. So when I went there, we saw that Japan is actually focusing on IoT and they call it Society 5.0, which is very much aligned with Industry 4.0. So what they're trying to do is, I would say, what developing countries, what they're trying to do is they're trying to move on to machines, rely on machines than human, of course. What is the reason? Because that would be less costly. And of course, machines are sometimes more precise. And to me, while I was there, I saw that there is only one excavator that would take aerial view from the drone, and the excavation will be done automatically. So that is replacing thousands of humans work. So there are machines which are developed that can count the items, and we know that maybe within very short time, call center agents and drivers and few engineers, of course, their job will be replaced. Why? Maybe sometimes we know that might be because we will invest on capital expenditure, but the labor cost will be saved. At the same time, we know that even if you think of today's world, maybe you are also replacing human with machines. I'm sure you are using, all of us are using washing machines and then dishwashers and dryers in our home. Why? Because that is cheaper, the operational cost is cheaper. At the same time, my washing machine or dryers, those don't get tired, or if there are too much load, they will not say, I will not come from tomorrow. So, of course, machines will replace human. We cannot do anything on that because industry is moving from Industry 2.0 to Industry 3.0, and now we are moving towards Industry 4.0, where we are focusing more on IoTs than AI and advanced manufacturing, robotics. So we have to accept the fact that actually we will have to manage projects where we will have to apply AI, IoT, machine learning, and all those things. We cannot deny that. So just after coming back from Japan, I have put my son into robotics class. Why? Because I want my son to be up to date with the society that we are moving on to. So I congratulate, I thank the Pearl City Hyderabad chapter for arranging such a timely topic, bringing in such a timely topic, because we will all have to be aware of like what is going on in the country, in the region, in the world. So we will have to be aligned with what is going to be in the world. So thank you so much. Over to you, Kritika.
Thank you so much, ma'am, for sharing your experience. That was very insightful. Now I would like to invite Dr. Krishna Kumar, a passionate entrepreneur and the president of PMI Kerala chapter, to speak a few words. Over to you, sir.
Thank you. Thank you, Kritika. And good evening to all of you. I hope I'm audible. And I would like to thank PMI Pearl City Hyderabad chapter for the opportunity to share our thoughts in AI. I feel most of the audience is from the project management community, and the big question what we always ask is that, can AI be used in project management? The answer is yes. Like Srini was already saying, that as one continues to store and collect information, we are indirectly contributing to the big data of the organization's repository. Using Alexa, Google Home, Siri, we are communicating with the AI systems that perform day-to-day tasks, and it will be like our job is also very similar to that. And if you are doing the same job and doing the same task every day, there will be some pattern, and it can be automated, right? A chatbot will check the status of the project so quickly. Maybe there are different projects as well. An algorithm that can apply machine learning and predict the estimation of the different tasks. Allocation of the right resources to the right project can be done with the help of an AI that can monitor the resource pools differently and predict when the team needs more attention. Right? The AI can tap into a large data series by understanding whether is there any previously occurred risk which has been there or previous incident which is there, and identify whether it is having a similar kind of an occurrence now and calculate the likelihood whether this risk can predict here or not. So everything can be, AI can be used very effectively in project management. And another big question comes is that, is the project manager jobs are in stake because everything can be done through AI, right? But according to me, the answer is a big no, because like Shavin already said, right, AI will assist, not replace the project managers. And like other technologies, AI alone cannot guarantee any success. However, AI can be surely a distinctive accelerator or a game changer to the project managers that will help increase the project success rates. The project managers who be very much succeeded in using these new technologies or the emerging technologies and can add real value to the project will be the game changers in today's industry. And let's be adaptive to the new normal, and let's embrace all the AI in our projects. Thank you, and thank you to Pearl City chapter once again.
Thank you for your insights, sir. Now I would like to invite Syed Nazir Razik, President of PMI Chennai chapter. He is a very versatile professional, a collaborator, and an early adopter of technology. Over to you, sir.
Hello. Yeah. So good evening all, and thanks Gopalan for a great session of citing business cases and application where we can put AI to good use. One of the key takeaways for a PMI chapter that I see can be using of AI and machine learning in deploying a chatbot for the chapter, right? We should leverage your expertise and guidance to build an AI-powered chatbot for PMI chapters that facilitates conversational growth online. And the other point that I wanted to make is everybody talks so positive about AI, but I have a slight variation on that. Not everything is rosy about AI. On one end, there is this hanging threat that AI will replace human effort, but the real threat is in the machine-trained models deployed under hood with an intended outcome, right? Putting data to work, supporting machine learning models, and thereby AI. I come from being a very ardent evangelist of social engagement, and we are creating petabytes of data every day on social, right? The scary fact is that today, from the time you get up, every interaction that a person has with technology is recorded as a data point in a very dispassionate way. And that data point, comes to the back end and it gets put together into a model, right? 3 years back at PMI, we were very actively talking about social listening to understand sentiments of users and towards a particular brand like PMI, so on, right? Knowingly or unknowingly, right? We have started training machines to do this and take trained decisions based on data patterns. And this is very scary. Like every person is getting profiled and grouped into something else, and we are being fed information which is very customized across our social channels. So that is scary, in fact. And with that thought, I would like to leave this wonderful session. I feel that this should be a start of a long-term engagement of building something on AI for PMI chapters. Thank you.
Thank you, sir, for your inspiring words. Now I would like to invite Mr. Madhav Reddy, President of PMI Pearl City Hyderabad chapter, to speak a few words. Madhav is a multifaceted leader with more than 2 decades of experience in steering organizations to greater heights. He's a mentor to a few startups too. Over to you, sir.
Thank you, Kritika. At the outset, I'd like to thank all the participants who have joined today. Mr. Gopalan for a fantastic session, Srinivasan, Managing Director, PMI, and all the R11 leaders who had given their time for this session. Thank you very much. Now, after hearing to Gopalan and all the speakers, I think I'll just add a few more points on the AI side from the point of view of what is that is in store for us. I think that also has been to a great extent discussed. But I think the point that Syed was raising more from the point of view of the job loss, or I think his concern was more on the thread that it comes as far as the data point that we are leaving on the web and someone is trying to analyze that data and profiling us. I think that's the biggest concern that we have. But on the other side is that the kind of jobs that we are going to lose. That there is a study which says that about 75 million jobs would be displaced by AI. But at the same time, the same study says that there will be 133 million new jobs to be created. Now it is for the fraternity of PMI as well as our members that we need to look at that what is that's going to change in the next 3, 4, 5 years, and how do we prepare for that change. Unfortunately, a lot of us are having experience or having a background of engineering to a great extent. There is a possibility of adding these two, because AI standalone would not be until it is backed with understanding of that subject, understanding of, for example, chemical engineering. AI has to have the brain which adds up from the people who are having that kind of experience. Because AI would take the raw data and disconnect the data and data points and try to come out with certain interpretation, and that interpretation has to be right, and that input has to come from people who are from that particular industry. I think domain experts would continue to play a significant role, but it's time for domain experts to actually take on AI as additional learning, I think it's a good time for us to actually do that. As far as impact of AI is concerned, I think no industry would be left out, whether it's transportation, manufacturing, healthcare, education, media, customer service, tax are there. But there is a great opportunity for AI to be used by the government as well in crime control and management of crowds in many of the large programs that we all do. So lot of things to be learned as far as AI is concerned. I think we have to be prepared for the new future. Over to you, Kritika.
Thank you for those inspiring words, sir. After an engaging learning session, now it's finally time for an exciting quiz. To take us all on a roller coaster ride, I will now hand over control to Mr. Manohar Yerraguntla, Director of the PMIPCC Academy, to conduct the quiz. The questions in the quiz will be based on the presentation.
Thanks, Kritika. Good evening, everyone. I know many of you are waiting for the quiz. We have typed in many of the times the link where you can play the quiz. Again, for the benefit of all the audience, I will say how exactly you can play the quiz. We have two options to play the quiz. The first option being, I hope many of you might have downloaded Kahoot app through Google Play Store. Or in case if you have not downloaded, then the second option is you can go to your web browser and type in kahoot.it. Then that will prompt you to enter a PIN. Okay. Yeah, either you can go to the app or you can go to web browser and type in kahoot.it. And in a moment, I will show you the PIN. Using that PIN, you can enter the game. So before we move on to quiz, there are a few ground rules we need to follow. The first thing being, you need to have two devices to play this game effectively. The first is the screen which you are seeing, the WebEx screen, that being your primary screen. But if you want to join the game, you need to have a secondary device, either your iPad or maybe your mobile. You can where you will enter the actual PIN. So the question and answer, if you see on the right hand side, left hand side, you can see the question and answer will be displayed on the screen, but you cannot select the answer on the screen which is shared. So in your device, you need to select out of the four options, you need to select what is the correct answer. Okay, just I will give you the PIN, and once the PIN is displayed, I will give you some more instructions. So the game PIN is 1989202. Oh my God. I can see a lot of people are pro in Kahoot. Oh, that's great to see. 150, around 150 joined. Oh my God. Wonderful. We have around 200 plus participants. I'm sure all the 500, I can see around 500 attendees in the list. I'm sure all of you should join the game. It just doesn't test your AI capability, AI knowledge, but also gives you opportunity to earn exciting prizes. So don't miss this opportunity, guys. We are touching close to 300. I will allow couple more minutes for others to join. Who is the 300 guy? Yeah, before everyone joins, I will tell you the next set of guidelines. We have 10 questions, and every question will have 30 seconds. First the question, will be displayed on the main screen. Then you will get the answers. Then by the time you see the answers, you have 30 seconds, and within 30 seconds, you need to select the correct answer. Here you need to consider two things, not just the accuracy, even the speed also matters, because the points are distributed based on the correct answer. At the same time, if the fastest finger first, if you type the question first, the answer, if you have selected the answer first, then obviously you will be getting more points. So I can see around 325 participants. We can wait for 1 more minute. At the end of each question, we'll show you the leaderboard position. And on a leaderboard position, the top 5 will be displayed over there along with the points. And you can see the top 5 names over there and how many points they were. Here we have 338. Okay, I'm just checking, is there any questions in the chat window? I don't see any questions. Yeah, you can toggle to browser, but the problem is you will lose the time. So it's always better to have 2 devices so that you can answer pretty quickly to gain some additional points. Yes, yeah, you need to enter only in one device, the pin in one device. Okay, I will wait for 10 seconds and then we'll start the quiz. Okay, 5, 4, 3, 2, 1, and here we go. I'm starting the quiz. In the interest of time of everyone, let's start the game. And yeah, just the final instruction before I start the game, there are 2 dummy questions that they are the practice questions which doesn't carry any marks. So the first 2 questions just to get some hands-on about this Kahoot game, how exactly you need to play. Then you will have the marks starting from the 3rd question. Okay, team, I'm starting the game now. Here you go, 3, 2, 1. The first question. How is the weather today? It's a dummy question. Now you can see options on your secondary device where you have entered the pin. On your secondary device, you don't see the question. You can see only 4 options with the color. You need to select the correct color or correct symbol. Great. We have around 320 people participated in this particular quiz out of 350. And yeah, let's move on to, nothing is right or wrong. Let's move on to the next question. Yeah, you can see Khan, Zay, all this 5 on the leaderboard position, but without any scores. Let's see the next dummy question. PMIPCC was started in. Oh my God, I can see a lot of pros in the team. You guys don't require 30 seconds. We thought that we will give you some additional time. That is where we kept 30 seconds, but looks like this team doesn't require 30 seconds. 10 minutes should be fine, 10 to 15. Great. I think all of you have got some hands-on on the Kahoot app. From next question onwards, you will have you will have points. Not just, again, I'm reiterating, it's not just the correct answer, it's the fastest answer also. The person who gives the first correct answer, he will get more points. Okay, team, I wish you all the best. And here I'm going on to the third question. From here, you will have marks, which is not a subfield of AI. Okay, I can see 138 as answered correct. And I can see pretty good participation from all those 360. That's good to see. Let's see who is on the leaderboard position. Okay, now these are the top 5 on the leaderboard position. That's great to see. You can see there's just a fraction of points difference. That might be the maybe millisecond, fraction of second difference by the time they touch their mobile screen or secondary device. So always you need to be very accurate at the same time fast. Let's move on to the next question. Second question. Which type of algorithm is used for predicting stock market prices? Oh my God, oh my God. Amazing. Don't be in a rush to answer first and type a wrong, choose a wrong answer. Be accurate, that is more important. That's great. We can 204, around more than 70, around 70% of you are right. That's great to see. Let's see on the leaderboard position. I'm sure there will be a lot of changes. You can see. Okay, then Funny has climbed to top position, and we can see these are the top 5. And again, you see there's only fraction, very, very, very small difference between each of them. And in those who are not on the leaderboard position, don't be worried. If you can answer 3 questions in a row, correct answers in 3 questions, then you will be on the leaderboard position. Let's move on to the next question. Which algorithm is used for predicting whether a project manager will participate in an AI workshop? Oh God. Now I'm thinking, unfortunately, I can't change the time now. Oh my God. Everyone is. Okay, 120 correct answers. All the options are evenly distributed for all the 4 options. Let's see who is on the leaderboard position. Okay, again, Funny pushed back to 4th position, whereas Vijay climbed to top position, and so Rohini, Funny, and Avi. Again, I can see just a small difference between each of you. That's great to see. Yeah. Let's move on to the next question. Which is not a type of variable? This should be an easy answer. Okay. good percentage of correct answers, 158. Let's see who is on the leaderboard position. Okay, here you go. Sai has climbed to the top position, and Fanny retained the second position along with Vijay, Arlene, and Pankaj on the 5th position. Here you can see. Yeah, let's go on to the next question. AI as a field is gaining popularity across domains because it's a very interesting question. Oh my God, that's amazing to see. Nearly 80% of your, more than 80% of your answer is the correct one, 268. That's lowest cost of computing is the correct answer. Let's see who is on the leaderboard position. Okay, again, Funny Rate climbed back to first position and he pushed Sai to second. And I can see Prafulla has came on leaderboard position. And again, I'm saying 3 correct answers in a row, you will be on leaderboard position. Still, we have many more questions to go, team. Those who are not in leaderboard position, don't be disappointed. Please ensure that you give an accurate answer and type as quickly as possible. Let's see the next question. To develop and test AI algorithms, data needs to be
Manohar, you need to mute.
Currently, we are facing a technical glitch, so please bear with us.
Hi, Komal. Am I audible now?
Yes, sir.
Yeah, thanks. First of all, sorry to everyone for this technical glitch. Yeah, Komal, can you make me presenter again?
How many questions we have covered so far?
I think 5 questions, Madhav.
Out of?
Out of 10, we have another 5 questions, and yeah, we didn't lose the game. Still, the game is on.
Oh, I see. Okay, great. Then you can continue.
Yeah, we can play. It's just pause, so we can resume from there. Okay.
So let's continue and maybe reduce waiting time. You can directly go to the next question.
Yeah. Just I'm trying to share my screen. Can you see my screen, Venkat?
Not yet, Manohar.
No, Manohar.
Yeah, I don't know. I'm presenter, but it's not allowing me to share my screen. Can you make me host for a minute, Komal?
Yes.
Yeah, I'm clicking on this share screen, but it's not getting activated. Just in a minute, maybe I can drop off and come back to this webinar.
So you can see the leaderboard, Manohar, because logging off will take time. So if you can announce the leaderboard and we'll continue to the next topic.
Okay. Okay. The leaderboard position is Sai on the top, followed by Vijay, and the third position Prafulla and Sandeep, and fifth position Shweta.
Okay, great, Manoj. I think thanks everyone for participating. I think there is some issue sharing on our desktop, so we'll stop the quiz here. So we'll move on to the next topic. Mohan, is that okay?
Yes, apologies for that technical glitch. We will stop the quiz and continue with the leaderboard in terms of the last question. We will share the announcements, the names that were announced by Manohar. Please do reach out to Manohar, and we will share the prizes details with you directly. Thank you so much for your participation. Hope you enjoyed whatever quiz we could cover for today, but hopefully next time we'll have a greater session. Continuing with the remainder of the session, Kritika, over to you.
Yeah. Now I would like to request Ms. Komal Mathur to deliver the closing remarks and bring this engaging learning event to an end. Over to you, ma'am.
Thank you. Well, three words kind of describe today's evening. Little extended, but it was certainly engrossing, insightful, and exciting. Gopalan had a way to decompose the complexity of AI, and we were introduced to various elements of AI today. We became aware of the opportunities in the field of AI. Now, as leaders, we will need to actually drive the adoption of AI in our projects, and also at the same time upskill our PM fraternity to be future ready. The inspiration to host these mega events comes from our spirited members. A big thank you to all the PMI members and the PMI fraternity for participating today and making this event a big success. A thank you to all the volunteers who worked behind the scenes to make this event a success. A special mention to Kritika Meher, PMIPCC volunteer, Swati Damle, board member Mumbai chapter, Region 11 Social Media Task Force team, Region 11 Common Calendar team, and all the Region 11 leaders for the extended support all throughout this event. A big thank you to Dr. Srini Srinivasan, Mr. Girish Kadam, Lieutenant Colonel Sri Harsha, Shamima Begum, Dr. Krishna Kishore, Syed Nazir Ulbek, and Madhav Reddy. You have all shown us the future of project management and the role of technology in our projects. I would like to also extend my deep gratitude to Roger, Priya, and all the PMI India staff for the continued support. Exactly a year back, our wonderful PMI PCC team delivered a highly successful project management national conference. Today, I want to thank them again for the generous and welcoming support. A special mention to Manohar for conceptualizing and conducting the quiz. I would like to thank the star of the evening, Mr. Gopalan, for his wonderful case study-based learning insights. We look forward to your continued support. As leaders, it's time for us to take new strides in establishing standards for AI-based project management, upskill our PM community, and live up to the reputation of being a nation's largest pool of next-generation talent. Let us all get ready to use AI everywhere. Let us all continue to be safe and connected. Thank you.
Thank you, ma'am, for bringing all of us together this evening. May I now request all the speakers of the day to please switch on their video for a memorable group picture.
Thank you. Thanks for sharing the screen. And Kritika, over to you.
Can you share the screen, ma'am? A few quick announcements regarding today's sessions. The next slide, please, ma'am. This event is eligible for 2 PDUs. Please use the claim code displayed on the slide to claim your PDUs. PDU information will also be emailed to you. PMI chapters are an exciting community of professionals and a great platform to network, volunteer, and continue your professional development. We urge you to join a PMI chapter. The link to join the PMI Pearl City Hyderabad chapter is in the chat window. I would now like to inform all the attendees for the upcoming events. First, the virtual PMP preparatory workshop on 26 September for all PMP aspirants. The link for the same will be shared on the chat window. We also have PMIPCC member network meeting on the 26th September 2020. The link for the same is posted on the chat window. I urge all PMI members to register for the event. As always, it promises to be an exciting and an engaging session. Wow, here we are at the end of today's session. I would like to thank all the stakeholders, the PMI community, for joining in today and making it a successful networking and learning experience. You will all be receiving a post-session mailer with requests to feedback and details of PDU. The recording of the session will be made available to a later date on PMIPCC's YouTube channel. Do stay tuned. May I request you to share your feedback when exiting the WebEx meeting. Have a great evening and see you all at the next event of our chapter. Until then, stay safe. Khuda Hafiz.